Hello fellow gamers, my name is Brent Justice. Welcome to the FPS Review's YouTube channel. Intel Microcode 0x129 has been released as of August 2024 to many motherboard manufacturers, and motherboard manufacturers now have BIOSs that are out for motherboards that are now in non-beta status. They are official BIOSs. So it's time, or is it time, and that is the question, to upgrade to the new Intel Microcode 0x129 BIOS, which is supposedly a mitigation for instability issues or problems arising on 13th, 14th gen CPUs that are not degraded and do not have issues. This fix potentially will fix those issues from happening or your CPU becoming unstable. Now, that part of it has yet to be tested, and it will take a lot of long-term testing to figure that out, and that's not why I'm here today. What I'm here for today is to look at the performance of the Microcode 0x129 update and just see if it causes any kind of performance degradation on a CPU, so that when you install the update, you will know, will this performance be degraded? Will I notice a difference, multi-thread or single thread, or will my gaming be slower because of this fix? And that is simply what we are here to test. Now, if you are not familiar with the Intel Microcode 0x129, this is the latest mitigation that Intel has released to fix non-degraded CPUs in order to keep them from potentially degrading or having reduced performance over time. And this is among many fixes that have come over the last several months. The very first fix to come was in May of 2024, where Intel released new profiles to motherboard manufacturers. This would be the Intel default profiles, and you can find several of those in the extreme profile or the performance profile. In addition to that, in June of 2024, Intel released the Microcode 0x125 update, and what this did was alleviate some thermal velocity boost issues that were occurring with the CPUs. That was part of the fix. And then this is the third. Is it the final fix? Don't know, but this is at least the third fix, 0x129 microcode update, which basically limits the voltage beyond peaking 1.55 volts. So your voltage should not peak beyond 1.55 volts, and this should potentially keep the CPU from degrading if it is not an already degraded CPU. It's extremely important to understand this update will not fix a broken CPU. If your CPU already has degradation, this will not fix that degradation. This will not make it go away. In fact, it could make your CPU even more unstable, as higher voltages were making it stable previously. So we can talk more about that in the summary, but this is mainly for non-degraded CPUs to potentially keep your CPU from hitting that degradation point. So this is a culmination of three different fixes: Intel profiles, the thermal velocity boost fix, and then finally now the microcode fix for voltage spiking above 1.55 volts. But I am simply here to test what 0x129 does, since it does limit voltage a little bit. The question is, will it degrade performance? And I'm going to test that. Now, how I'm going to do that, I am using an Asus Tough Gaming Z790 Pro Wi-Fi motherboard. On this motherboard, there is a new BIOS that I am testing, 1663, that has this microcode update. It is a non-beta BIOS. It is fully officially released. Now, before that BIOS came out, there was the previous BIOS, which was 1661. On the 1661 BIOS, that had the 0x125 microcode, so that did have the Intel thermal velocity boost fix on that BIOS. And it also had the profiles, where I could select extreme or performance profile in the BIOS with the Intel default profiles. So this gives us a perfect platform to test just the 0x129 update, microcode update. We can test directly from the 0x125 to 0x129 between the 1661 BIOS on this motherboard and the 1663 BIOS. So the only change that the new 1663 BIOS has is this Microcode 0x129 update. So I will already be testing on the 1661 BIOS the new Intel default profiles, and I'm testing both the extreme and performance profiles, and that update also for the Intel thermal velocity boost. That is also already applied on that 1661 BIOS. So it's real simple. We slap on the 1663 BIOS, we have the 0x129 microcode in place, and we do a retesting, and we are able to then directly compare performance between that BIOS and this BIOS and see if this new update with the reduction in the peak voltages causes any kind of performance degradation on the CPU in multi-threading, single threading, and gaming performance. It's that simple. That's the test. You can go to our website, www.thefpsreview.com, where we have a written review of this, where we have all of the percentages calculated out under each graph, so you can read our analysis and summary from that full review. So if you miss any of these charts or you want a longer look at the graphs I'm about to show you, check out our written review where you can read those graphs and study them a little bit more and see what that performance was. We tested synthetic benchmarks, so we could look at the multi-core and the single-core performance, and we also looked at rendering performance, testing all the popular rendering applications, and then of course gaming. We have 8 games worth of data, and we looked at the performance there to see if this causes any kind of degradation on your gaming performance. And then we summarized, and that's exactly what we're going to do in this video as well. I'm going to go through each graph and talk about it and show you the performance here in this video, and then at the end we'll summarize. So let's take a look. All right, now let's take a look at the graphs. Again, we are using an Intel Core i9-14900K CPU. We are testing with the motherboard at the extreme profile and the performance profile so that we can show both performance and extreme profiles and just see if between the two profiles, if the microcode update has any kind of performance difference. Obviously, there will be a difference between the extreme and performance profile anyway, just because of the limitations they have in their performance, and you can of course see that here in 3D Mark, but we knew that already from our initial review when we re-reviewed all these CPUs with the latest profile updates. So we have the Microcode fix 0x129 is highlighted in blue, and the gray bars is before the Microcode fix, so that's BIOS 1661, and then again the blue bars are BIOS 1663, which do have the microcode fix, and that is the only difference. So we're going to start here in 3D Mark CPU profile test. This is the max threads, testing all the threads on the CPU. And what we can see here is that the numbers are just a tiny bit under the numbers before the update, after the update just a little bit. But if you do the percentages, that is literally a 0.3% difference in performance there. And that is what we would call margin of error or negligible there, under 1%. And the same is also true for the performance profile. Now this tests maximum thread performance. So in a multi-core workload, that's about what we're seeing is a 0.3% difference, something that would be imperceptible. Looking at the one thread or single thread test in 3D Mark, we can see here that, well, the performance is exactly the same. We are a point off, and that's about it with the new microcode update, a point off. So that shows that for single core, at least in this test, performance is unaffected with the microcode update. Moving on to Geekbench, we also find very similar performance, just like we did with 3D Mark. Geekbench is more varied in its workload than 3D Mark, and with a more varied workload, the performance is literally extremely small here. Let me look at the results here, but the percentage difference was, yeah, again, 0.3% is what the this calculates out to, about 0.3%. So extremely small. And then when we go to the single core, we see exactly the same thing that we saw in 3D Mark single core testing here as well. There's no performance difference. If there is one, it is extremely tiny. We're talking a 0.1 or 0.18% difference in performance here with the single core. So extremely negligible, something you're not going to notice. Now, moving on to performance test. This one is a kind of an all-around benchmark that shows more of a system-level benchmark. And for this one, it is about a 1.1% difference. So there's a little bit more of a difference with this one, especially with the extreme profile here. It was actually 1.1% faster with the extreme profile. So that is interesting and actually shows something that we thought might experience as well, that if you are not throttling the CPUs as hard, you're not throttling because of higher power, that maybe it can actually obtain a higher all-core frequency if you're not pushing it as hard, and sometimes that can happen. So in this situation is 1.1% faster, but we're actually literally talking about a 1.1% difference, still negligible even if it is that much faster. And as for the before and after in the performance profile, the difference is 0.06. Extremely small there, extremely small. Now, moving on to IDA64, we're testing the memory bandwidth read and write here. And on this one, what this basically shows is that the memory bandwidth is unaffected with the microcode update. There's no change in the bandwidth. We're still operating at the same read and write bandwidths here before or after. So there's just no difference. Bandwidth is the same. Now, moving on to the zlib test. This is an integer-based test, and this one's actually pretty good for showing results here. I want to get the results for you. 0.3%. So that's what we're seeing. So here's the before, and then with, the numbers are slightly under. I mean, you'll see that it's a benchmarkable difference. It is slightly under, but when you do that, the calculation, it's literally a 0.3% and a 0.5%. So that is extremely tiny. We're talking under a 1% here. It's 0.5% difference. So in the grand scheme of things, very small for that. Moving on to the AES test for encryption. Again, we are looking at a 0.05% difference on the before and after with the profiles here. A 0.05% difference, and in the performance profile, the microcode fix was decreased by 1.4%. So a little bit more with the performance profile versus before, because the performance profile was way up here on the top on this one. So now it's down here. So that's a 1.4% difference. I mean, that's still very small. We're talking almost 1.5% difference. But this is a very focused test where it uses that encryption testing. It is an extremely focused test there, a very specific workload. So if you were doing that kind of a workload and you had like a lot of CPUs doing that kind of a workload, sure, it would add up. But for a desktop user, probably that's not something you're going to notice. Now for the SHA-3 test, I mean, you can see that the performance is pretty much dead on there. We're talking a 0.16% difference and a 0.15% difference, so very negligible for this test as well. Now moving on to everybody's favorite Cinebench R23, we're getting into the rendering performance here. Before the microcode fix, 38092, and then after 38075. So yeah, it's just a few points under, but it's so small. I mean, when you do the calculations, it's 0.04%. So that's real small, and then 0.18% for the performance. So we're talking extremely small here, not negligible for a multi-core workload in Cinebench rendering. Now moving on to the single core performance, we actually got a point higher here, or a couple of points higher, and we saw this in another previous test as well, where performance could sometimes be just a little bit more with that microcode fix, and that is again because perhaps the higher voltage was throttling it just a little bit, just enough, and then taking that limit off allows it to push forward just a little bit and be just a little bit faster. But obviously I mean, we're talking percentages here that you simply would not notice here. 0.3% again. Again, we see that 0.3%, very common here. Blender, same thing in Blender. Again, this is a very focused workload. We're seeing a 0.2% difference. And then with the performance profile, again, it was 0.47% faster with the microcode fix, but again, 0.47. So that's very small, even if it is technically faster, under 0.5% here. That is very negligible. We see this also in the junk shop scene. Very similar performance here. I mean, this is practically the same performance. And then we go to the classroom scene, and I mean, literally, it's the same performance. 112, 112, 112, 112, just a 0.3, 0.8, 0.9. So small, so insignificant there with that workload. V-Ray 6, I would say, had a little bit of a bigger turn than some others, but even with these high numbers, when you do the calculations, it's 0.6. It's still under 1%, so 0.6% for V-Ray here. So that's extremely small. For Handbrake, this one's a little bit interesting because, once again, in the extreme profile before the microcode fix, it took 8 minutes, 0.01 to render this, and then it was 8 minutes flat with the microcode fix. So just a hair faster, but can you really say that that's noticeable? No. And then the same thing here, just a hair slower with the performance one, 8.08, and then to 8.1. That's in minutes and seconds. So it's so minor that it's just hardly worth talking about. I will show the power. We'll get to the power. I know I just flashed that real quick. We'll get to the power here in a second and take a look at the power and temperature. But before I dive into the power and temperature, let's look at the gaming performance and see how does this affect gaming, or does it? Now let's look at the gaming performance. For the gaming performance, we are using an NVIDIA GeForce RTX 4090 FE, and we are testing just at 1080p for these tests, just to see are there any differences. And we'll start with Alan Wake 2 here, running at the highest game settings, and practically it's the same performance. We're talking 171 FPS in the performance profile between both, and 179 FPS in the extreme profile. Obviously a big difference between the extreme and performance profile. That for sure is a difference. But between the microcode fix and before the microcode fix, no difference. 0.9, 0.7. If you do that by the math, that is a 0.5% difference here and a 0.4%. So again, we're back to that 0.5% or under 0.5% difference between the before and after microcode, and this is in a game. So I mean, this is practically the same performance. Once again, we look at Assassin's Creed Mirage, and I mean, it really cannot get any more clear than that. The microcode fix just doesn't change performance at all. I mean, 1 FPS faster in the performance profile, but I mean, what's that really? And in the extreme profile, it's the same. So nothing there at all. Avatar Frontiers of Pandora, exactly the same thing. Between 171 to 173, but in the extreme profile, 173 to 172, and in the performance profile, 172 to 171. So 1 FPS difference. Literally, again, that's nothing margin of error. That's not a practical difference there, really. Cyberpunk, everybody's favorite. We can definitely see that there is a performance difference between the extreme and performance profiles, for sure. But when we look at the microcode fix, we'll start here on the performance, 211.7 to 211. Very, very small. 214 to 213. That one's a little bit bigger. Let me bring up the calculations here and get that for you. So that is a 0.6% difference between these two. Still under 1%, so a very small difference there for Cyberpunk. And this one usually shows differences like this when they occur. We look at Dying Light 2. This is another game that is sensitive to CPU performance, very sensitive, but even in Dying Light 2, we're not really seeing a huge difference. I will say this is maybe one of the bigger differences out of the games that we saw. You could even call that an outlier, but in the grand scheme, it's a very small difference. But with the microcodes, they are both under the before microcode. But look at the frame rates we're already at here, 242, 243, and then 241. If we do the percentages, that's a 0.9% difference for the extreme profile and a 0.3% for the performance profile. Or is it the other way around? No, it is a 0.9% for the performance profile and 0.3% for the extreme profile. So 0.9%, so the almost 1%. So I would say that almost 1% is like the largest difference we saw there, an almost 1% difference, which is pretty negligible. It is benchmarkable, but negligible. Horizon Forbidden West, also seeing the same thing there. Very similar performance. It is just, again, a hair below what the microcode. But, I mean, we're talking a hair here. What is that? 0.34% and 0.57%. So, again, 0.5%, under 1% of difference in Horizon Forbidden West. Returnal. This one, exactly the same performance in the extreme profile, no difference at all, and a frame faster with the microcode fix, so definitely not slower, but also negligible. And then Starfield, one that is also sensitive to CPU as well. Performance is exactly the same, 141, and then we just go down to 140 for everything else. It's the same performance there. Now, we did do an 8-game average, and we looked at averaging all 8 games performance across the games at 1080p here, and that's how it comes out. I'm just bringing up the percentages here. So in the extreme profile, the average is 0.35%, 0.35% slower with the microcode fix before the microcode fix. 0.35% across 8 games, very small. And the performance BIOS, or the performance profile, exactly the same. So I guess with the extreme profile, you see that hairs of that thin hair of difference between them because of the profile. But in the performance profile, things are evened out just a lot more. Basically no change if you're using the performance profile in gaming, and if you're doing the extreme profile, we're talking under 1% average here, 0.35 again, well under 1%, under 0.5%. So that is very, very insignificant in terms of performance difference with that microcode fix. But now let's take a quick look at the power and temperature, and then we will do a summary. Okay, power and temperature is just going to be very easy to talk about because all of these CPUs are locked at 253 watts, 253 for PL1 and PL2. Whether you're in the extreme profile or the performance profile, PL1 and PL2 locked at 253, and therefore with the microcode fix, there is no change. Your power is locked at 253. Keep in mind, this is a maximum or peak wattage usage reported by Hardware Info of the CPU package power, but this is a peak wattage of Cinebench running for 10 minutes. So this is not reminiscent of what you would get in a game. This is a maximum rendering type application, and we are hitting that maximum PL1 and PL2 with no change in the power. Now, what did change a little bit was the CPU temperature, and this one was a little bit shocking, but I did double check this. So first of all, in the extreme profile before the microcode update, 90C is what we got. And then after the microcode update, 91C. So a 1 degree difference. I wouldn't call that anything there, but it's really in the performance profile where things changed. Before the microcode fix, it was 95C was our maximum temperature, and then with the microcode fix, that actually went down to 90C. So that voltage, that less peak voltage with the performance profile, actually reduced the CPU temperatures there. So that's worth noting. If you're concerned about the cooling type you're using in your computer, or you cannot afford a massively expensive cooling type, running the 14900K in the performance profile with the microcode fix, you should get a little bit lower temperatures there. So you might not need such a beefy cooler for the CPU in that scenario. That's just something interesting that was worth noting there. The other thing that I want to talk about is the frequency. We did look at the peak frequency in all-core and single-thread before and after the microcode. And we found that a couple, like maybe 1 or 2 of the P cores during an all-core load would be maybe 100 megahertz slower, and that is during an all-core load. and this was either with the extreme profile or the performance profile. So with the extreme profile, there was like an extra P core that was running 100 megahertz higher, and in the performance profile, there was maybe just one P core that was running 100 megahertz higher than the others. With the microcode fix, it reduced one or two of those P cores that were running at a time by about 100 megahertz. So that would account for some of the performance differences in an all-core workload. When all the cores are maximized and working at full throttle, you may see a couple of the P cores operating 100 megahertz slower than they were before. And that's at least what was happening with our CPU. Can't say that would happen with every CPU, but that was what was happening with our CPU, but it's not extremely significant as you saw in the performance results. But that's the frequency difference. Now, in a single core, single thread performance, the frequency was exactly the same. They all reached the same frequency between both BIOSs. So there was no change in frequency in a single core application. Okay, so now that we have taken a look at the CPU temperatures, the power, and the frequency, and again, you can go check our review to see all these results. We also have screenshots of those frequencies, and we talk more about that in the review as well. So check that out if you want to go see that. But now let's just do a summary of basically what we've learned from all this testing today. All right, that is our look at the Intel Microcode 0x129 update and how it affects performance. We used an Intel Core i9-14900K and a Z790 motherboard from Asus with the latest BIOSs. We did the 1661 BIOS versus basically the 1663 BIOS, so we could directly compare the microcode update and how it affects performance. In our testing, I would say that what we found is during a single core or a single thread workload, there is no performance difference at all with the new microcode update. You will lose no performance in that type of workload. Most of any performance lost is a benchmarkable performance loss, and only in multi-core or multi-thread applications. So if you do a lot of multi-core usage, you may see under a 1% degradation in performance or reduction in performance with this microcode update. Now, I can't say that will be for every CPU. I can say that will be for our CPU, but some CPUs are binned differently, and so yours may perform better or differently with that voltage. In our testing with our CPU, though, we lost maybe 0.3 to 0.5% performance in the extremely very loaded, full throttle multi-core, multi-thread type rendering and applications. That's really where we lost that performance, but we are again talking under a percent here. The biggest difference we saw was maybe 0.9%. It is very small. So these are going to be imperceptible things here. You're not going to notice that difference. You're not going to feel that difference. It is practically the same. It is the same. For gaming performance, we did see maybe a 1 FPS difference. 1 FPS, but again, everything was under 1%. Even in the most extreme ones that were the outliers, it was still under 1%. And our average across 8 games was only 0.35% difference, which is extremely small. This was also tested in a scenario again where it's 1080p with a 4090 trying to push the CPU as hard as possible. And that's only where we saw the difference. If you're playing at 1440p or 4K, or you have a video card that's not a 4090, there will be no gaming performance difference at all. You will not notice it. Even if you have a 4090, you're not going to notice the gaming performance difference. So I think that's pretty much our summary. In single core, single thread, there is no performance difference. In multi-core or multi-thread, there is an under 1% difference, maybe 0.5%. Now, that's not something you're going to notice or feel. It's not a practical difference. And unless you're running multiple of these CPUs in a server farm and you are, constantly rendering media or doing something that requires that type of multi-thread, multi-core computational work, sure, that will add up. But in a desktop situation, and these are desktop CPUs for the end user For the enthusiast, for the gamer out there, you will not notice any performance difference upgrading to this Microcode 0x129. So our recommendation completely and fully is to upgrade to this new Microcode update. Update your BIOS if you have a 13th gen or 14th gen Intel CPU. Whether it be a K, KF, KS series, it doesn't matter. If you have an i5 and i7, that as well, i5, i7, i9, upgrade. Check your motherboard manufacturer for the latest BIOS. We do not recommend upgrading to a beta BIOS. We do recommend waiting for an official BIOS. Upgrade to it, however, and you will have the Intel profiles available where you can select extreme or performance, or maybe perhaps other ones as well, depending on the motherboard. But you will have those Intel default profiles available. And then the 0x129 will hopefully perhaps prevent degradation on the CPU from occurring. Now, I must stress again, this update will not fix a broken CPU. If you have a CPU that already has degradation, and that is a hard thing to figure out if you have or not, but if you have degradation, this won't fix it. This will only prevent a CPU that does not have degradation from potentially, untested yet, degrading. That's it. So keep that in mind about this update. Very important. But we do recommend updating anyway. And the other thing we wanted to mention, which we mentioned at the start of the video, is if you have a CPU that has degraded and is taking a higher voltage to remain stable, like for example, it was peaking already above 1.55 volts, but it needed that voltage to be stable at the frequency, then there is a chance that upgrading to this microcode with a degraded CPU will actually cause instability, because now you are starving the CPU of voltage, peak voltage it might have needed in certain workloads to be stable. And if you choke it of those voltages, then it will suddenly become unstable. So I would say that if you apply this update and you are immediately having stability issues with your CPU and you are running the Intel default profiles, then you might want to examine further if degradation has occurred on your CPU. That would be my recommendation. But I definitely recommend that everybody upgrade to this BIOS to help save your CPU. If you're worried about it, do it. You should absolutely do this update. You will not get a performance loss that you will notice, and at least that's one good thing out of all this. The mitigation, thankfully, is not going to be a huge performance loss, other than the Intel default profiles, which was already in place before all of this. So I just wanted to put this video out and get that information out there for anybody that has 13th and 14th gen Intel CPUs. The Microcode update has now been released to motherboard manufacturers. It's in an official non-beta status. And based on our performance results anyway, I don't see any reason not to upgrade to the new BIOSes with this update. It should not cause any performance degradation. It shouldn't cause your gaming experience to go down. And at the end of the day, that's a good thing. But let me know what your experiences are in the comments below. If you've got an Intel CPU, you're having degradation, or you're not having degradation, you've installed these BIOSes, let us know your experience and how this is working out for you. I'm trying to provide as much information as I can in the testing that we can do, and get this out there so that you're aware of these new updates and any performance differences or changes because of them. So again, this full article is on our website, www.thefpsreview.com. Please check it out. Please read it. And thank you all for watching. Have a very blessed day, and stay tuned for the next one.